All right, ladies and gentlemen, welcome to 2.3. We're applying slope, midpoint, and length formulas. So we've done a lesson on each of those. You know how to build equations of lines and relationships between x and y that have linear relationships. You know how to make say that a point satisfies an equation and how to use that information in developing linear equations. So now we're going to put it into some word problems. We're going to put it into some situations where you're going to have multi-step problems that use all of the formulas that you have learned so far. Okay, so on the front page there, you have two little columns. The first one is the 4 steps of problem solving. All right, 4 steps of problem solving that you're going to use that are going to help you through this type of stuff and for the rest of the semester and the rest of your life. Number 1, first thing you want to do is make sure you understand the problem. Understand the problem. What's going on in the situation? What are you actually trying to figure out? Understand the problem. Once you understand it, you can choose a strategy. Choose a strategy. So last unit, you would have been choosing between, substitution or elimination in order to solve for a variable. In this case, you're talking about linear relationships and the intersection of two lines, or how variables interact with each other, those kinds of things. Once you have determined a strategy that's going to work, another thing about choosing a strategy, you might list, I need to find this. In order to find that, I need to do this. In order to do that, I need to do this. In order to do that, I need to do this. Okay, then you start working from the bottom up and get those things that you need. That's carry out the strategy. Step by step, carefully marking each step as you go along. Then you're going to reflect. Did I accomplish what I set out to accomplish? Did I find what the problem asked me to find? All right, on the right-hand side there, you have your formula list. Okay, formula list. What are some of the formulas that you know and that you might need? What's that? Okay, so you got a couple of different equations of a line. Okay, let's go start from the easiest one, which would be slope y-intercept form. Y equals mx plus b. Never going to want to forget that. And we have another one, we said point slope form. Y minus y1 equals m times x minus x1. Good. Any other formulas you've used in the last week?
M bracket x y bracket equals.
Good. Okay, so midpoint formula. I'll take your answers and then I'll put them in an order that I want you to put them in.
I don't know which one it is, but it's the one where actually it might be different. Where you have like y1 minus y2 in brackets and then like a fraction.
Yeah, that's.
Okay, switch y2 minus y1 over x2 minus x1. That's slope formula. Yep, Julia. Okay, so we could also have a standard form of an equation. You can, yeah, let's write it. Sure, why not? Ax plus by plus c equals 0, where a, b, and c are integers, and a and b cannot both be 0.
The one, I don't really know how to find it. But you have two, like a and b, let's say, equals, and then the root.
Yep, so you're thinking about the distance or length formula? Okay, I'm going to write them down. Here we go. The next one I want you to write is slope m equals y2 minus y1 over x2 minus x1. There's your slope formula. If you have 2 points, you can find the slope of the line that goes through those 2 points. All right, then we have a midpoint formula. Midpoint, because it's a point, is going to be a capital M. Notice slope is lowercase m. Okay, it's a characteristic of a line, and it is a coefficient. It's a variable in front of, or it's not really a variable. It's an unknown value or a value that you're going to find out in front of the x, whereas midpoint is a point on the line. And the midpoint formula, well, you take the average of the two x coordinates of the 2 points that you know that are on the line, and you take the average of the two y coordinates of the points that are on the line, and then that'll give you your midpoint. Then you have a length formula or distance. Either way, what I'm going to write, I'll call it distance. D equals, it's under this big radical square root symbol, and it is the difference in your x coordinates of the 2 points that you know squared plus the distance in your two y coordinates of the 2 points that you know, square that, and then take the square root of the whole thing. Just as a quick reminder, where does this thing come from? Well, let's say you had a line like this, and you have x1, y1, and you have x2, y2. The difference in the x coordinates is this distance here. The difference in the y coordinates is this distance here. That gives you a triangle, a squared plus b squared equals c squared. So c equals the square root of a squared plus b squared. That's what's right here. This is literally just c equals the square root of a squared plus b squared. Where does that come from? It comes from a squared plus b squared equals c squared. Okay, if you need that little helpful note, you can go ahead and do that, or do it on the bottom, whatever you want to do.
Isn't there also like one with elimination?
Let's head into example 1. There's a little note at the bottom that says, use your space carefully. This problem is long. Okay, so you're going to probably do some work in a column and then give me a little arrow that says, okay, I'm going back up here, and keep going down. Maybe that's how I'll do it on the whiteboard as well. Please read carefully. You're trying to understand the question, and make sure you gather all of the important information. A ranger cabin is to be built in a flat wooded area near the straight road that connects the two campgrounds in a park. Okay, you can see that road from A to B in your picture there. And a new side road is going to connect this cabin site to the campground road. All right, on the park map, you have the campgrounds at point A and point B. And the site for the cabin is at point R. And each unit on the grid, on the map grid, represents 500 meters. Our goal is to build the shortest road possible. Okay? Just going to draw this out for you a little bit so we can think about it. You don't need to draw this out. But let's say we've got campsite, and we've got our cabin right here. Okay? What can you tell me about the shortest road possible? Am I going to have a road going this way and meet here? Am I going to have a road going this way
No.
and meet here? Am I going to have a road going this way?
Yes.
What about this one? Is this one a good one?
No.
What about this one? Is this a good one?
No.
What's different about this one?
It's closest.
Ah, look at that. The relationship between my original road and the new road is that they will meet at a 90-degree angle. They are perpendicular to one another. So what am I looking for in my new road?
Perpendicular line.
Okay, keep going. Hadassah?
Give us something.
Sienna? What am I looking for in my new line? If they're going to be perpendicular.
You have to look for the midpoint.
The slope.
thing.
Ah, we're talking about slope, not talking about midpoint. Talking about slope, and what has to be true about the slope?
They are the opposite.
And
Opposite reciprocals. Okay, here we go. Let's work through this. So we're going to build the cheapest, easiest road. It's going to meet perpendicular to the original road. And so what I need to do is get the, what's my goal? I need to find out the length of this line, or I need to find Yes, I need to find the length of this new road. And in order to do that, I'm going to need several things, okay? So I already have, well, let's start from the back. Let's say I need to find I'm going to write a list. I'm going to write our goals, okay? So our goals are to find length of road, okay? In order to find the length of something, in order to use my distance formula, what do I need? What information do I need?
You need the coordinates,
Coordinates of 2 points.
which you have.
Do I?
No, you only have one.
I only have one. I have the cabin. I don't know where the cabin road is going to meet the other road. Coordinates of 2 points.
Don't forget the midpoint of the midpoint.
Nope, it has nothing to do with midpoints. We already had that discussion. Literally zero to do with midpoints. Not at all. Nothing at all. Nope. Slope. Slope matters. Okay, good. But I need the coordinates of 2 points. Uh-oh. This is your greatest fear. Sky, you just mentioned this. Said, am I going to have to do this year? Not just this year. You're going to have to do this today. Okay? That's going to mean that we need the point of intersection of new road with old road. Okay? That's going to reach back into Unit 1, substitution and elimination. Now, in order to find the point of intersection, what do I need to know about those roads? How do I find the point of intersection? I need to have 2 equations. I need 2 linear equations. It's going to be a linear system. So I need 2 linear equations. Oh boy. I need the equation of both roads in order to find the point of intersection of those roads. Do I have 2 linear equations? Do I have 1 linear equation?
Yes.
I have the equation for that road?
No.
I sure don't.
Oh,
I have 2 points though. Okay, and if I have 2 points, I can find the slope. And if I have the slope, I can get it into a point slope formula. And then I can go to my new road and say, okay, slope is opposite reciprocal. And I have a point for that as well. Okay, so for one line, for the old road, I'm going to use 2 points. You should be writing really small if you're writing all this. 2 points to find slope, then point slope form. For the new road, then I'm going to go over to New Roadville. I'm going to use my new slope is going to be the opposite reciprocal of the slope that I get over here. Then I'm going to use point slope form. Okay, we've talked through it. Let's do it. So clearly I'm starting here with the old road. I've got 2 points, so I'm going to find the slope right away. Okay, that's going to give me the slope of my new road as well. So it's going to be an opposite reciprocal. Then I can find an equation for each of these. And then I can start doing find the point of intersection. Okay, you have your little diagram up in the top. I'm going to keep track of what we do here as well. We've got A, B, and cabin, C. All right. Actually, it's R. It's called R. So, step 1. From the old road, use the 2 points to find the slope. What are my 2 points? I've got M1 equals, draw my line. I'm not going to write my formulas each time just to save space, although you probably would. You'd write y2 minus y1 over x2 minus x1, but let's just carry on. I'm going to call the second point B my second point, so I have 4.5 minus 8.5 in the top. And then the bottom I have 10, take away 2. I'm just going to work across in order to save myself some space. I've got negative 4 in the numerator, and the denominator is 8. That gives me a slope of negative 1/2. I could keep working on this because I know I need an equation of this line, but I'm just going to, because I found M1, I'm just going to go over here and make sure I know what M2 is. What's my second slope going to be if my original slope is, yeah, it's going to be positive 2. And you can kind of see how this one's going. It's got a not a steep slope. It's got a slope of negative 1/2, and then this one's going to be pretty steep going up with a slope of positive 2. It kind of looks like that, right? Up 1, or up 2 over 1, up 2 over 1. Okay, so this one's going to have a slope of 2. Let's head back over to our old road so that we can get an equation for the line. Okay, I'm going to name this line. I'm going to say, I know I'm in old road, okay, but I'm going to call that line AB. That's what it is. It's the old road from A to B, right? And now I'm going to get a equation for that line using point slope form, okay? So I can do it 2 different ways. I'm going to use my point slope formula, copy it down here, sub in what I know. I know the slope of my original line is negative 1/2. And which point would you like to use, point A or point B? B? Doesn't matter too much, right? As long as you're consistent. Let's use point B. So we've got y minus 4.5. Then over here I have x minus 10. Okay, making sure I'm taking them both from the same point. Simplify this out. It's going to, I'll leave the left-hand side, y minus 4.5 equals negative 1/2 x plus 5. If you're confused about how I did that, I have a negative times a negative, which is positive, and I have half of 10, which is 5. Okay, or 10 divided by 2 is 5. Now I'm going to add 4.5 to both sides. Y equals negative 1/2 x plus 9.5. Okay, I'm going to call that equation 1. For now, I'm just going to leave it like that. I don't really like the form that it's in. I would probably like to multiply everything by 2 to lose my fraction and my decimal. It's also kind of awkward to have a fraction and a decimal in the same math sentence. Okay, they should both be decimals or both be fractions. But generally speaking, we leave slope in rational form to help us understand it. Anyways, we'll leave it like that for now. Even though it's ugly, it will come over here to our new road. We need to name this point. Okay, we kind of know where it is, but we need to give it a name. So I'm going to give it the letter D. I don't know where that point is yet. I've got no idea. Even if you're trying your best to draw it on a graph with grid lines, you don't know where it is. That's not sufficient. It will give you no points on a test to draw a line and guess where that point is. Okay, you need to use algebra to solve, to find that point. We're not there yet. So far, all we know is that it starts at R and it's going this direction. We're going to get an equation for it. We can do that because we know the slope and we know one of the points that's on it. We know where the new cabin is. We know it's at the point 6, 1.5. Okay? So I can sub those in their respective places for a y value of 1.5, a slope of 2, and an x coordinate of 6. That statement is still true because that point satisfies the equation. And I'm going to work that down. Just copy the left side. Y minus 1.5 equals 2x minus 12. Be sure that this 2 gets distributed to both terms inside the group. And I'm going to add 1.5 to both sides. Y equals 2x minus 10.5. Okay, negative 12 plus 1.5 is 10.5, negative 10.5. I'm going to call that equation 2. Now, I said I might multiply each of these equations by something because, well, let's see what we did so far. We got an equation for the old road. We got an equation for the new road. So we have 2 linear equations. Boom, done. My next goal is to find the point of intersection of those roads. We have a couple of strategies that we can use to find the point of intersection. We can find it using substitution, or we can find it using elimination. Take a second to think about which strategy you would like to use.
Substitution.
I'm with Jess on this one. I'm using substitution. I'm going to use substitution because I know that y equals this and y equals that. So watch what happens if I use substitution. You could use elimination as well, but watch what happens if I use substitution. And I'm going to convert these into decimals, everything into decimals. But I have y equals this and y equals that. That means I can just set this equal to that. Okay, if A equals B and A equals C, then B and C are also equal. So now maybe I'll make a little note for you. Find the point of intersection. And you can call that point D. Okay, not with brackets though, that's a little bit confusing. Let's use a comma. Point D. I'm going to scroll up and sub these guys in. I've got negative 1/2, which is the same as negative 0.5x plus 9.5, and I know that's equal to 2x minus 10.5. So I don't have any y's here. I just have one equation and one variable, which means I can solve. I like to have positive x's here. So I'm going to add 0.5x to both sides. It's going to give me 2.5x over here. And I'm going to add 10.5 to both sides. 10.5 plus 9.5 is going to give me 20. All right. Now in order to solve for x, I need to divide both sides by 2.5. You could do that in your calculator. 20 divided by 2.5. I'm just going to rewrite it like this. I've got 20 divided by 2.5. And in my calculator, it's going to tell me that is 8 or 8.0, whatever you want to write.
You also do 2.5 times 2.
So that tells me that this x-coordinate of D, the intersection, is going to be 8. What do we still need? We need a y-coordinate. For y, I'm going to sub back in to either one of my equations, okay? I'm going to do it in equation 1. No reason, really. It's negative 1/2. I know my x value is going to be 8. And I'm going to add 9.5, just copying down the rest of the equation. That tells me that y is going to equal, what's negative 1/2 times 8?
Negative 4.
Negative 4, okay? It's negative, and it's half of 8. So that's negative 4 plus 9.5, which is the same as 9.5 take away 4. It tells me that y is 5.5. All right. Therefore, D has the coordinates 8, 5.5. Now I'd go ahead up into my diagram and I jot that in. And as I'm jotting it in, I'm also going to just double check that that makes sense. Does it look like it's at 8, 5.5? Yeah, it's moved a little bit to the right from point R and it's moved up, and you guys can look at it in reference to your other points, and you have a grid. So it's not that hard to see. All right, we found a point of intersection, which means we have the coordinates of 2 points on our new road. Yeah, we have the site of the cabin and we have the point of intersection. So can we use our length formula?
Yes.
We sure can. Give me a second to clear the board here. Last step. Find our length and maybe make a little note. Find length of new road. In order to do that, we're going to use our distance formula or our length formula. I'm going to copy it down. I've got the difference in my x coordinates squared plus the difference in my y coordinates squared. And then I'm going to take the square root of the whole thing because that's going to give me a little right angle triangle here. And all I need to think about is a squared plus b squared equals c squared. Okay? Plug in what I know. Doesn't matter which point I call point 1 or point 2. Okay? But I'm going to be, I'll do r to d. So I've got 6. Actually, that's silly because that'll give me 2 negative numbers. Not that it matters because when you square a negative number, it's always going to be positive. But I'll do 8 minus 6. And in my second bracket, I've got 5.5 minus 1.5. Eight take away 6 is 2. 5.5 take away 1.5. That's same as 5 take away 1. That's 4. Make sure I keep my square sign coming through. I'll just do it in multiple steps. Under the bracket, what's 2 squared? 2 times itself is 4. What's 4 squared? 16. So I have the square root of 20. In a lot of cases, that's going to be a good enough answer. We actually really like exact answers. And because I'm talking about a specific road in this diagram, I'm actually going to name the line after its coordinates, after its points. So this is road RD. RD. Its length is the square root of 20 units on the graph. Okay? We're going to do 2 things. We're first going to give an exact, or given a, it's an approximate answer. Can you guys on your calculator square root of 20? Good, so we're going to round up to 4.5. And look at this, because it's no longer an exact answer, it's an approximate answer. We're going to put a little dot above our equal sign. That tells us that it's approximate. And now we need to convert that into meters. We were told that each unit on the map represents 500 meters. So what do we need to do to that? We need to take our 4.5 and multiply it by 500 meters. And that's going to give us a final length of 2,250 meters. So this side road is about 2.3 kilometers long. What did we need to do in order to find that out? Well, in order to use our distance formula, we needed the coordinates of 2 points. In order to do that, we actually need to find that one point of intersection over here in order to get the coordinates of our next point. In order to do that, we needed 2 linear equations. Now we're reaching back and doing that point of intersection by substitution or elimination. Either way would have worked. Okay? But to get 2 linear equations, we had to do it in 2 different ways. For the old road, we already had 2 points, so we could use slope and then find slope using a slope formula and then use point slope formula. Over here, we had to get the perpendicular slope because that would give us the shortest distance. Once we did that, we had slope and an original point that they had given us to find the equation of that line. And then we started just keep on working backwards. You find the point of intersection, find the length of the road. Okay? Again, keep it organized. They're long questions. Figure out what you're looking for, figure out what you need, and then start checking off those boxes. Okay, example 2 is talking about determining a geometric property. So if you actually look at the very front page of your notebook, you will see that this chapter is called Analytic Geometry, and there's a little definition given for you in the middle of the page, and it says Analytic Geometry, also called Coordinate Geometry, is a mathematical subject in which algebraic symbolism and methods are used to represent and solve problems in geometry. So it's essentially a mixing together or using at the same time of algebra, which is our math sentences and equations with using variables, and geometry, which is shapes and figures and polygons, etc. So we're actually talking about properties of a geometric figure. Geometric figure is just a fancy word for shape, and property is any characteristic about it. So, for example, a property of a square is that it has 4 right angles. A property of a square is that it has 4 equal sides. A property of a square is that the diagonals are equal length. There's lots of properties of different shapes and figures. You could think about different types of triangles. What are the different types of triangles? Do you guys know some of the different types of triangles?
Isosceles.
Okay, isosceles. The
Scaly.
rule for isosceles is that there are 2 equal angles, okay? Which also means there are 2 equal sides. Scalene has nothing in common, okay? No right angles, no equal sides.
Equilateral.
Equilateral has all 3 equal sides. Anything else?
Unequilateral.
What about this one? It's
Right.
Right.
a right triangle, okay? Those are all properties. You could tell things that are true about a right angle triangle or about an equilateral triangle. You'd be describing that figure, describing that geometric figure would be telling its properties, okay? So what can you tell me about anything special about a right triangle?
It has the right angle.
Yeah, tell me about it has a right angle, which means what about this purple line and this purple line?
Horizontal
They're
and
perpendicular.
They're perpendicular to each other, okay? They're perpendicular. So that would be a property of a right triangle, and that's actually the property that we're working with in example 2. So let's do that. The vertices of triangle ABC, do you guys have a picture of triangle ABC there? Excellent. Okay, so the vertices, I'm going to list them. Make sure we know we're in example 2. We've got A at 5, 5. We've got B at -3, -1. And we've got C at 1, -3. And we need to determine, is triangle ABC a right triangle?
yes.
Okay, and we have no idea yet. You might look at that picture and you might say, oh, it kind of looks like it is, but guess what? Looking at it and saying, oh, it kind of looks like it is, doesn't get you anything. It gets you a big old 0. You need to show algebraically. So, if triangle ABC is a right triangle, what is going to be true about it?
Oh, I know this.
We already said the answer that I'm looking for, so
It's gonna have a right angle.
it's going to have a right angle. Okay? Which angle do you assume is potentially the right angle?
C.
Yeah, we're kind of looking at ACB, right? We're thinking this might be a right angle. So then what does that tell me about AC and BC? They should be perpendicular. So the only way that I can test, there's actually 2 ways that I can test this. The first way that I can test this is if, let's just, maybe I'll write this down. So options for testing. First option we could do is that the slope of BC should be the opposite reciprocal of the slope of AC. Okay? Does that make sense? This slope should be the opposite reciprocal of this slope. That means, another way to say that, and this is the same thing, BC perpendicular AC. Okay? You need to learn those symbols and that symbolism. These things say the exact same thing. If BC, the line segment BC, is perpendicular to the line segment AC, then that means that the slope of BC is the opposite reciprocal of the slope of AC, and that would make this a right triangle. Okay? What other property exists in a right angle triangle? How do you relate the side lengths in a right angle triangle? You're reaching back in your toolbox of tools. Side lengths of a right angle triangle. All right, so the Pythagorean theorem should apply here. So that would mean that the length of A, square it, add the squared length of B, that should equal the squared length of C. Now we don't have those lengths, but we do have all of our coordinates. We have all of our points. So from that, we could get our side lengths and then see if it fits into Pythagorean theorem. If it does, it must be a right angle triangle. If it doesn't, it's not a right angle triangle. And the same thing here with slope. Okay, the strategy that we're going to take is using slopes. Okay, that's a little bit faster. So I'm going to just erase this. You can leave yours, but our option, we're going to go with option 1 for now, which is finding the slopes of all of these lines and then determining whether or not two of them are right angles, make a right angle or are perpendicular to one another. So I'm not going to assume that I'm just looking for this angle. I'm just going to get all the slopes of all the lines because let's say it wasn't drawn for me and I didn't know what it looked like and I didn't want to draw it. Then I would just get the slopes of all three and see if they line up. So let's do that. We're going to go for the slope of AB. Okay, copying down my slope formula, y2 minus y1 over x2 minus x1. And because it's a slope of AB, I'm using points A and B, and it does not matter which one I call x1, y1, and which one I call x2, y2. But I'm going to go start here. I'm going to go with A as my x2, y2. So I've got a 5 in the top and a 5 in the bottom. Y is 5 and x is 5. And then I've got B. I'm going to subtract -1 in the top. And I'm going to subtract -3 in the bottom. Okay, so I'm just plugging in my values where I know that they go based on my slope formula. I'm going to do a little bit of this in my head. This gives me 5 plus 1, which is 6. 5 plus 3 is 8. That gives me 6 over 8, which gives me a slope of 3/4. Okay, that one's done. That's my slope right there, slope of AB. Okay, I'm going to do the next ones a little more quickly. Slope of BC would be my next line segment. And I'm not going to use my formula again, so maybe I'll just start down here. Slope of BC equals. All right, let's go with -3 in the denominator as my x term, x coordinate, -1 in the numerator as my y coordinate, and then I've got my coordinates from C. So in the top I have -3, and in the denominator I have -1. -1 plus 3 is 2. -3 minus 1 is -4, and I'm just going to right away put that negative sign out front because I know I have one negative factor here. And that gives me -1/2. Now I need to do the line segment AC, and again, it does not matter if you write CA or AC. Okay, the slope of that line is going to be the same no matter which way you write it, as long as you're consistent in the way that you plug in your numbers. So I'm going to plug in my x and y and x from point A, and then I'm going to subtract -3 in the top. That's the y coordinate of point C. And I'm going to subtract 1. That's the x coordinate of point C. 5 plus 3 is 8. 5 minus 1 is 4. That gives me a slope here of +2. Do we have a situation where there are two line segments that are perpendicular to each other? Yes. How do I know that? Because these guys right here are opposite reciprocals. Okay, and I'd need to write a really smart math statement to justify this. I would say, since the slope of BC times the slope of AC equals -1. Okay, that's what opposite reciprocals do. The product of opposite reciprocals will always be -1. Okay, we learned that earlier. Since these are perpendicular, that tells me that angle ACB is a right angle. Angle ACB is a right angle. And that also tells me triangle ABC is a right triangle. Okay, quick run through. We needed to test whether or not triangle ABC is a right triangle. So we're talking about properties of triangles, and you need to determine, you need to think about, what should I test to figure this out? You know enough about slopes and opposite reciprocals to know that perpendicular slope, perpendicular line segments will give you a right angle, and that will make it a right triangle, or it will show that it is a right triangle. We didn't change anything about the triangle, we just identified it, gave it a name as a right triangle. Okay, so we determined that if those slopes were opposite reciprocals, if the product of two slopes equaled -1, then it would be right. So we tested all three line segments, got their slopes, found out two of them did form a right angle, therefore it is a right triangle. Okay, we're going to quick run through method number 2. Am I good to clear this?
Oh,
Okay, second method. Method 2, use Pythagorean Theorem. Do you guys have enough space to do another one?
I do.
Okay. If you do, that's great. If you don't, just try your best. All right, so Pythagorean Theorem, that means we're going to be looking for side lengths. So again, I don't need to, I know I'm looking for side lengths, and then I'm going to think about Pythagorean Theorem. So what am I going to do? I'm going to use my coordinates and my distance formula, my length formula, in order to get the length of each of these sides. So let's go with side length AB. I'm going to write down my formula the first time I'm doing this. I've got my coordinates up here, but first I'm just going to write down the formula. I've got x2 minus x1. Okay, that's the difference in their x values, squared, plus y2 minus y1 squared, and I'm going to take the square root of that. That's going to give me the length of that side. What did we end up doing here? Basically what we're doing is we're taking the change in x from A to B and the change in y from A to B. We've got a little right angle triangle there, and we're calling it side A, side B, and side C, and we're going to find out the length of AB there, okay? So now I plug in what I know. x2 minus x1. Again, it doesn't matter what order I plug them in as long as I'm consistent. So I'm going to go 5 minus -3 squared. And my y2 minus y1, I'm going to go 5 minus -1, close bracket, squared. Notice that I need a double bracket at the end of each one. That's because I've opened two groups. I opened a group at the beginning, and inside that group I have another group. This -3 is a group by itself. So I need to close both of those brackets off in both situations here. All right. I'm going to do two steps in one here. 5 plus 3 is 8. 8 squared is 64. 5 plus 1 is 6. 6 squared is 36. And this radical symbol, anything under there, is itself a group. So I need to deal with the stuff under the group before taking the square root of it. 64 plus 36 is 100. And we know that that length is going to reduce to 10, radical 10. 10 times 10 is 100, so the square root of 100 is 10. And there we have the length of AB. Okay? We're going to do that 2 more times. First for BC. I'm not going to copy down the whole formula again. Okay? But sometimes it might help you to do this. Just kind of set it up so that you know what you're looking at. And then you can plug in the values that you're looking for. So I'm using B and C. So I've got -3 minus 1. That's the x-coordinate of B minus the x-coordinate of C. And I'm consistent over here. I've got the y-coordinate of B minus the y-coordinate of C. Again, doing this part fairly quickly, and I'm going to do it all in one step. We've got -3 minus 1. That's -4 squared. -4 squared is going to be positive 16, okay? It's always going to be positive under the radical in this situation because a negative times itself would mean a negative times a negative, which is a positive. Okay, and a positive times itself is certainly positive. So we got negative 4 squared, which is positive 16. Over here we have negative 1 plus 3, that's positive 2. Positive 2 squared is 4. So we've got the square root of 20. Now that does not reduce to a nice value, so I'm just going to leave it as the square root of 20. This is called an exact value. The answer here, the length, is exactly radical 20 units. Okay, if you put in there 4.47 or 4.5, you would be rounding. You would not have an exact answer, but we want an exact answer for this one. All right, I'm going to squeeze the length of AC over here. In the first bracket, I've got 5 minus 1. And the second bracket, I've got 5 minus negative 3. Make sure both those brackets are getting squared. And in one step, I've got 5 take away 1 in this group. That's going to be 4 squared, which is 16. And here I have 5 take away negative 3, which is going to be 8, and then square it is 64. Add those up, you get the radical of 80. Well. Now we need to check. We're going to apply Pythagorean theorem. So we have the length of each line segment. That's good to go. Now we're going to see if Pythagorean theorem works out. So in Pythagorean theorem, basically what we're looking for is a situation where a squared plus b squared equals c squared. Now we're gonna line this up, and we're gonna just do it left side, right side. Okay, we're gonna ask. So if I have the left side of my Pythagorean theorem, I'm gonna make those my two legs, the squares of my two legs, and I'm gonna add them up. So the left side is going to be bc squared plus ac squared. And the right side is just going to be AB squared. Okay, I'm going to explain that out one more time. Basically what I'm suggesting is that if this is a right angle triangle, it will be true that the square of this side plus the square of this side over here is equal to the square of this side over here. So if I end up with left side equals right side, then I know it's a right triangle. If left side doesn't equal right side, it cannot be a right triangle, or at least this isn't the right angle. But I'm expecting it to work out. So here we go. BC is right here. It's radical 20. So I'm just going to copy that down. Radical 20. And this is where you need to be careful. BC is radical 20, but I need BC squared. Okay? Same thing with AC. AC is radical 80, and I need that squared. I'm going to keep working down this left side. This part looks confusing. It's actually really easy. You don't need your calculator at all. Square rooting and squaring are inverse operations. They undo each other. So this is like adding 10 and then taking away 10. You just get the number you started with. Or multiplying by 2 and then dividing by 2. You just get the number you started with. So if I take 20 and I square root it and then I square it, I'm just going to get 20. Okay? Same thing over here. If I take 80, I square root it and then I square it, I'm just going to get 80. Okay, so that's 100. Let's look on our right side. We've got AB squared. Well, that's going to be pretty easy since AB is 10 and we have 10 squared. We know that's 100. So I do have left side equals right side. Therefore, triangle ABC is a right triangle. If it were not a right triangle, Pythagorean theorem would not have worked out here. Okay? So there were two totally different ways to test whether or not this was a right angle, a right triangle. Did any of them involve measuring an angle? No. Okay? Did any of them involve getting out your protractor and being like, oh yeah, it looks about 90? No. Okay? It was all coordinate geometry. These are exact values based on the position of these points, and you prove with certainty that it is a right triangle. All right, here we go. Example 3, median to a hypotenuse. So example 3 is again dealing with a geometric figure. You have a diagram there with the coordinates of 3 points. It's actually the same triangle, isn't it? It's the same triangle that we worked with in example 2. And what do we need to do? We need to show that the median from the right angle of the triangle is half as long as the hypotenuse. Let me draw that out for you, okay? So you have a diagram there. I'm going to try to copy the diagram fairly accurately. Something like that-ish, okay? Nope, that's pathetic. I need a right angle. There we go. Okay, here's our right angle. We just decided that angle C was a right angle, okay? And now it's saying that we need to draw the median from angle C. So there's my point at angle C. What's a median again? A median is a line segment that extends from
vertex to the midpoint.
to the midpoint of the opposite side. So mine's not exact, but basically what we're doing is we've got 2 equal line segments there. So we're finding the midpoint here. We're going to call that point D as we move along. And what this thing is saying is that this line is half the length of this line.
That's a thing.
Is there a way of just looking at it and seeing it and knowing it?
Oh.
No, there's not. Okay? So what do we need to do?
Find the median. Find the lengths.
So we need to find their lengths. Once we have both their lengths, we can compare them. Okay? So here's my little list of things to do. Find length of AD and length of DC. Do we have enough information to find the length? Oh, sorry, it's not AD, it should be AB. AB is the hypotenuse. Do we have enough information to find the length of AB?
Yes.
Yeah, we have 2 points. Okay, we've got the point B and we've got the point A. And actually, we already did this work in our last problem. Okay, we already have the length of AB. That's the hypotenuse. It was a length of 10, right? Square root of 100, length of 10. So we could just say we already have this. This is 10 units. Do we have enough information for the length of DC?
No.
Can I just look at my graph and figure out where point D is? No, I can't do that. Okay, how can I find point D? Find point D using midpoint formula. And then that's it for this one. 2 steps. Okay, find point D, then find the length, use that point to find the length of DC. And from there, then you're just comparing the lengths, seeing if it really is half the length. So let's dig in. We're going to let D be the midpoint of AB. And then we're going to use the vertices A and B as our points, as our endpoints, and to find that midpoint. Do you remember your midpoint formula?
Yeah.
M equals
X1 or X something.
Over
X1 plus
x1
X2
mine's
over
oh, yeah,
2.
plus x.
Divided by 2.
It is.
Plus the other one.
Divided by 2
It's not
plus
plus,
y2
it's not plus,
plus
comma.
y. I remember.
Okay.
That.
This is, pay attention, this is 2 separate formulas put into one, put into coordinate form. Okay. The only thing, you have 2 separate things here. You have that the x coordinate is the average of your starting x coordinates of the endpoints. And then you have that the y coordinate is equal to the average of the y coordinate of your 2 endpoints. Okay? You are going to be doing problems where you actually need to separate these things out and pull them out and just deal with the x's and then just deal with the y's. Or sometimes you'll have actually be given an endpoint and a midpoint and have to find the other endpoint instead. Okay, that's not this one yet. But for this section, finding D, I called it M over here. I shouldn't have done that, okay? I was just, because that's the, I guess it's fine, because that's the general term. But we need the point D. XY is going to be the average of my x coordinates. So I'm looking at point A and point B. So I've got 5 plus negative 3 over 2 as my x coordinates. My y coordinate, I've got 5 plus negative 1 over 2. Can do that math fairly quickly. 5 take away 3 is 2. 2 over 2 is 1. 5 take away 1 is 4. 4 over 2 is 2. So go ahead and check if D is actually at the point 1, 2 on your graph.
Nailed it.
Okay, if it's not, we did it wrong. If it is, then we did it right. Not that you can always trust the pictures. The pictures are not always trustworthy. Okay,
Still
your math work is trustworthy. All right, so we have our point that we need. Now we can head into finding the length of DC or CD, whatever you want to call it. Okay, so the length of CD, that's just, you can just call it line segment CD, capital C, capital D. We know the formula already, so I'm not going to copy it down, but you would typically have your list of formula right in front of you when you're doing your practice problems. I'm just going to do this to help me remember that I'm doing a squared plus b squared equals c squared. And basically what we're looking for here is the change in x and the change in y to make a right angle triangle. And a squared plus b squared equals c squared. That's going to give us the length of this red line here. So the coordinates of our points here in the first bracket, x2 minus x1, we're going to go with 1 minus 1. And in the next bracket, we have 2 take away negative 3. First group, 1 minus 1 is 0. 0 squared is 0. Okay, I'm going to write that just because, even though you don't need to, because you already know it. And actually, we already squared it. 0 squared is 0. 2 steps in 1. Okay, 2 take away negative 3. What's that?
5.
5. Good. So, not square root, squared. 5 squared is 25. 0 plus 25? 25. Square root of 25? 5. Okay, I'm going to do that in 2 steps so that you can see it. And it's 5 units. Now, was there any change in x?
No.
No. It was a straight vertical line. So just the vertical change made up the whole length of this line, which is fine.
I'm still confused with you.
So we've got CD equals 5 units. And we know AB equals 10 units. So is it true that the median from a right angle of a triangle is half as long as the hypotenuse?
Yes.
It is true for this specific case. So let's write a little closing statement. Since CD equals AB over 2, or you could write it like this, 1/2 of AB the median from the right angle is half the length of the hypotenuse. Okay, now that we've done an example using the median of the right angle in a right triangle, you actually now need to know that property. This will be true in every right triangle in the whole world, that this, the median from the right triangle, is going to be half the length of the hypotenuse every single time. No matter how big, no matter how small, no matter how stretched that right triangle is, if it's a right triangle, Okay? Then the median from the right angle will be half the length of the hypotenuse. Okay? Okay, your practice problems for lesson 2.3 are listed on the bottom of the page there. It's a worksheet that is included in your booklet. It's worksheet 2.3. You are responsible for numbers 3 through 9, 16, 17, and 20.
You say 20?